morning, good evening, good afternoon, whatever time it is for you guys. So, today we're going to be doing momentum and impulse. A couple of questions here and there. So, this is for revision. I'm going to be doing a lot more questions, and the starting point for what we're going to be doing is going to be on this momentum and impulse, and we're going to dive more into other things as well, such as vertical projectile motion, other things in vertical projectile motion. So with momentum and impulse, there are many other factors that you need to actually know. I highlighted these factors on the slides that I provided to you guys. Things like knowing the definitions, what is momentum, knowing what is an isolated system, knowing what is the principle of conservation of momentum, Newton's second law in terms of momentum, knowing what is impulse, what is an isolated system, elastic and inelastic collisions, um, and basically knowing how to use the guideline when studying. Those are the learning objectives that I provided in the notes that I had given to you guys. So, right, let's get off into it. Momentum and impulse. So, our first question says two trollers, one of 1 kg and another one of 1.2 kg, are stationary, as you can see, next to one another with a spring between them compressed. If the spring is compressed, you know that there's going to be a force that's going to be exerted between um, those two stationary trolleys. And then they say that, so basically that force or the spring, it contains a potential energy. And then they say that when the spring is released, meaning that whatever force that was keeping them compressed is now no longer there. They move in opposite directions. If 1 kg, if the 1 kg trolley moves off at 1 meters per second, calculate the velocity of the 1.2 kg. So as you can remember, one of the main things that I told you guys is whenever you have questions such as these, it's always nice to always first write down the direction that you want to choose as positive, since that's going to give you like a relative um, way when you're going to be working your things. So for this one, as always, usually the direction that we take positive is going to be the right. So we're taking the right as positive. On your answer sheet, this is not how you write it. You know that you just have to write that we're taking right as positive. So another thing that I also encourage for you guys is that when you write all of this, you might want to categorize the objects that are inside your system. And when you categorize those objects, you're going to be writing exactly the following. So first of all, in terms of the 1 kg object, we would call it, if it was called object A, we would call it object A, but that's not the case. So in terms of the 1 kg object, it has a mass of 1 kg, that's given, and the other one has a mass of 1.2 kg. The velocity of this, let's call it v1, let's call this m1, let's call this m2, let's call this v2. And it's also nice for you to actually indicate or annotate which object you want to make object 1 and which object you want to make object 2, if that's what you want to do. Unless if you want to write mass of 1 kg and annotate the other one as the mass of 1.2 kg, that's fine. It might save you some time if you want to do it like that, but if you feel more comfortable writing it this way, that's also fine. So the velocity of the 1 kg, it's going to be negative 1 meters per second. Why is it negative? Because the direction that we chose is positive, is to the right. And then the unknown velocity, we're just going to write v. So when we answer this question, remember that so basically, first of all, what principle of application would you use as you approach into this question, and why would you be using it? So for the topic of momentum and impulse, you have a set of equations that you could be using for whatever set of question that you're given. So what you need to know is how exactly you should be applying those things. So first of all, look at the quantities that are being measured or that are being expressed You have mass and you have velocity of two objects. And apart from that, you also have the fact that these two objects are exerting forces on one another, and there is no other object that is exerting a force on it. So it's only the focus in this question is only the forces that are exerted between these two objects. So this gives you an idea that these are action reaction forces. Remember, there was a time wherein I was telling you that in terms of action reaction forces, why exactly is it that you cannot classify weight and normal forces, action reaction forces, because it kind of feels like they could be or like they should be because of the fact that they are acting on one object and one is on the opposite direction and then the other one is um, on the other direction, and also because usually you're going to be having your weight being equal to your normal equal to your normal force, excuse me for that. But the idea is that it's going to be equal if it's on a horizontal surface. But the idea is that's not necessarily how we focus into this, and that's not actually what action reaction forces are. Action reaction forces or action reaction pairs are two forces that are exerted by two objects, one on the other one and one on the other one. So these are forces which are exerted individually by individual objects, and one force cannot exist without the other one existing. And that's the thing that you need to know, and also the fact that they occur in different directions. So that's one thing that you need to know. So things like applied forces between two objects, those are called action reaction forces. So in your multiple choice question, that's one thing that you need to note. Um, yeah, so looking forward into why exactly or what type of approach you should be using here. So we talked about the mass, we talked about the fact that you have an isolated system. And how is it an isolated system? Because you only have these two objects exerting forces on one another, and there's no external um, exertion of force from any other point. So, given those two facts, and also given the context of the question is implying that given the information that you have, it's possible for you to get the velocity of the other one, given the mass, the two masses, and also given the velocity of one object, is actually possible for you to get the velocity of the other one. So they're telling you that. Now you have to look into all the equations that you have thus far on momentum and impulse, which one actually allows you to go forward with this process. So you go to your formula sheet, which again, the thing with this is that what I advise is that when you go into your exam, you should be knowing the formulas. You should have practiced to an extent that you know what you want to use. So in this particular circumstance, the formula that we're going to be using is the formula for the conservation of linear momentum. And I will explain later why exactly we call it linear momentum. Uh, right now, let's try and answer this question. So we figured out the fact that you have these quantities over here. So what you can do is just come and write P initial for 1 plus P initial for 2 is equals to P final for 1 plus P final for 2, right? Now you don't have to start here. You could start from saying MV or M1 V1 initial plus M2 V2 initial is equals to M1 V1 final plus M2 V2 final. Now we enter the things that we need to enter. So the mass of the first object is 1, all right? And then its velocity, it's minus 1. The mass of the second one is 1.2. Okay, so this is the initial. Sorry about that. The initial velocity is 0. The initial velocity of the other one is 0. Why? Because these things are stationary, all right? I was getting a bit ahead of myself there, but yeah. And then you have 1 on this side, the mass of the object on this side, and then you have the final velocity for the 1 kg, it's minus 1. plus 1.2 v. Remember, we were just going to annotate it as v, right? And now it's just a matter of us busting out our calculators. So what you get from this is going to be 0 plus 0. So on the left hand side you have 0, on the right hand side you have minus 1, and then you're going to have this plus 1.2v. This one goes on the left hand side and it becomes 1, and then you have 1.2v, 1.2, 1.2, and then your velocity becomes 0.83 meters per second. Direction, remember that. Direction is going to be right. Or you can write it as a statement, just say to the right. That is given the fact that you would have mentioned that, let's assume that this one is going to the left, right? Or maybe this is, if they give you a diagram and you see that this one is going on this side, you don't really have to mention or like annotate that this one you're assuming that is going to the right. But if you don't have a diagram, you can assume that, hey, this one, let's say that this one is going to the left and this one is going to the right. That's okay, right? And but if you don't want to do that, if let's say that maybe you don't want to do that, you can just say that opposite original direction. Just take this away. Opposite direction of mass 1 kg trolley. That's what you could say. So sorry for the mess here, but that's how you would approach this question. So yeah, I did say that I would explain why exactly do we say linear momentum. So it said conservation of linear momentum because that's the only thing that you're going to be considering. You're going to be considering momentum on a straight line. So you're not going to be considering things from, on a 3D kind of scope. This is just what you're going to be doing on a straight line, going from zoom to zoom, or not even going anywhere, but it's just a matter of the fact that these are just going to be things that are going to be meeting each other here, or a force is going to be going in that direction, or they can follow one another on that direction. And that's one thing that I wanted us to know, which is the fact that in terms of conservation of momentum, it doesn't mean that in these collisions, you're going to be having things staying in the same place. Things can actually move away at the same velocity, right? And given that fact, let me explain this one thing for you guys. So let's say that you have the same question, right? You have a question entailing that you have a mass of 1 kg, and after the release of the spring, the mass of 1 kg moves away at a velocity, let's say, of 2 meters per second, right? And to the left, so minus. That means that we're still considering a direction to the right as positive. And then they say that the mass of 2 kg, let's say 2 kg, right, moves away with, or let's say that they don't give you the mass, right? But they say that a mass of x kg, right, moves away with this with the trolley of 1 kg at the same velocity, right? So if both these two things are moving away at the first initially, they rather, let's give this one also an initial velocity. So this is the final velocity, right? And then this is the initial velocity. Let's say that the initial velocity was -5. You can see that I'm pulling these questions out of my head. Yeah, so let's say that this was the initial velocity of this one, and let's say that the initial velocity, so this is the final velocity of this, And let's say that the initial velocity of this one was, let's assume, around 1 meter, right? Around 1 meter per second. So you have these masses. You have a mass of 2 kg. No. A mass of x and a mass of 1 kg. Now the mass of 1 kg has an initial velocity of -5 and a final velocity of -2. And then the mass of x kg has an initial velocity of 1 and a final velocity of -2, means that it moves away at the same velocity, right? So given that instance, you're going to write out your formula, you know, um, m1 v1 initial plus m2 v2 initial is equals to m1 v1 final plus m2 v2 final. So if you want to be fancy, what you could do is just come and write m1 v1 initial plus m2 v2 initial is equals to v final into m1 plus m2. Right, you see that? So that is the circumstance that we have currently. So how does this work? If you can, one of the things that I emphasize with you guys is that when you read a question, try and visualize what's going on. So if you had an object of 1 kg moving in that direction initially, it would be moving in, sorry, in this direction at -5 meters, right? And then when moving in that direction, it meets an object of 2 kg. But this 2 kg object is moving in that direction in 1 meter per second. So it makes sense that this one would end up, okay, not 2 kg. Why do I keep saying 2 kg? It's x, right? Now it makes sense that this one would end up decreasing its velocity to -2. And this one would actually end up taking its velocity of -2 given whatever mass that it has. But primarily what makes sense is that this one would take a lower velocity. Same direction, sure, but lower velocity because it's meeting an object that's going on a different direction. Most likely if they were both going in the same direction and this was of a relatively smaller mass, this one was going to result in a superposition. So basically you would have a superposition of these two velocities and gaining an even greater velocity, right? Because the mass here matters. So let's try and answer this question. So let's consider this as m1 and let's consider this as m2. And now the mass of the 1 kg trolley is 1 and the initial velocity is -5. And then the mass of the other one is x. We don't really know it, right? You don't have to use x. We're using x because that's what we're given. And its initial velocity was 1, right? See it given there. Now both of them move at -2, so 2 meters per second to the left. And then you have m1 and m2, right? So what's up with m1 and m2? M1 and m2 are basically just different types of masses. So your mass for this one is going to be 1, your mass for the other one is going to be, well, quite unknown. And when you want to solve this, that's going to give you -5 plus x is equals to what? -2, right? Minus 2x. Make sense? Nice. So primarily what we want to do is to get the variables in the side of the equation wherein they're positive, and so this one is going to come on this side. You're going to be having yourself x plus 2x is equals to minus 2 plus 5. These are going to give you 3x, and this is going to give you what? Just like that, comprendo. It's going to give you 3 divided on both sides, and x is equals to 1 kg, right? So this is the point where I want to emphasize the following things. Direction. I really want to emphasize this direction. Direction has got to be emphasized. Because imagine if I had made a mistake here in terms of direction. If you make a mistake in terms of direction, let's say that I had said that, this was actually positive. It was going to give me an entirely different answer, most likely an answer that doesn't really make sense. You most likely might have even gotten like a negative mass, which really doesn't make any sense. And that's not what we're actually looking for, right? What we're looking for is an answer that actually does make sense, and also an answer that is carried by the right procedure. And for you to actually carry the right procedure, I'm not saying this to give you, stress. I'm saying this to tell you that, hey, you should be mindful of something, right? So that's one thing that I want you to consider. And one other thing I want you to consider is visualization, right? When you get questions, you need to be able to visualize, especially in your multiple is an answer that actually does make sense, and also an answer that is carried by the right procedure. And for you to actually carry the right procedure, I'm not saying this to give you, stress. I'm saying this to tell you that, hey, you should be mindful of something, right? So that's one thing that I want you to consider. And one other thing I want you to consider is visualization, right? When you get questions, you need to be able to visualize, especially in your multiple choice questions. You need to be able to visualize. You might get a question like this in your multiple choice question or wherever it may be. Um, Another thing is if you want to do, you can be, creative. You don't necessarily have to do this. But what I want to emphasize also, most importantly, rather than any other thing, is the first equation that you write should be an equation that is on the formula sheet. Regardless of whatever manipulations that you're going to make, it's imperative and very important that the first equation that you write is the one that's on the formula sheet, because that has a mark. As a free mark that you get right there. Another mark that you get is a mark for placing these values inside the places where they actually do make sense. You don't get marks for this. See this? This. You don't get marks for this. This is physics, not mathematics. You get a mark for this, right? So most likely for this, you're most likely just going to be looking for 3 marks. But 3 marks are quite important in your report card if it's only going to be looking forward to, if it's only going to be using your answers from your exam. Your marks would be, that those 3 marks are enough to actually get you a point above or a point below what you actually want to do. So consider that. So that's an example of conservation of momentum, and I hope that that was quite helpful to you guys.